Okay, so let us go to the question here. Question number 4. 3 point charges plus q minus 2q and plus q are placed at points. X is equal to 0, y is equal to a, z is equal to 0, x equal to 0, y is equal to 0, z is equal to 0, x equal to a, y is equal to 0, z is equal to 0 respectively. The magnitude and direction of electric dipole moment. Okay, in such questions, all the time, if you see, all the time, one variable will be 0. For example, look at this question. Z is equal to 0 for the first charge. Z is equal to 0 for the second charge as well. Even for the third charge, Z is equal to 0. Which means you don't have to consider the Z axis. Then what? What I have drawn must be XY plane. So the one left right is X axis, up down is Y axis. So I'm going to forget about this Z component here. All the Z components are cut. I'm going to put the charges. Where are the charges put? Plus Q is placed at where? Which location? Plus Q is placed at 0, A. 0, A means somewhere here. This location is called 0, A. Right there I'm placing a plus Q. And look at the next plus Q. Look at the next plus Q. That is placed at which location? X is equal to A, Y is equal to 0. A, 0. That must be here. A, 0 must be here. This is my second plus Q. And what about the third charge? The middle charge is minus 2Q, which is at? The middle charge is minus 2Q, which is at X is equal to 0, Y is equal to 0, which means it is at the origin. This minus 2Q is at the origin. So this is the structure of the system. I repeat one more time. First of all, in such questions, one coordinate will be 0 in common. Here in this question, Z coordinate is 0 for all the points, which means our configuration lies in XY plane. Our configuration lies in XY plane. Okay. And I'm placing the charges at the locations. First charge is plus Q, as you can see. First charge is plus Q. So before that, I'm just scoring that Z coordinate off. Z coordinate is not needed. I'm looking at X and Y only. So first charge is located where? It is at 0, A. So I'm putting at 0, A, the first charge. That is the first charge. And the third charge is again plus Q, which is to be put at A, 0. A, 0 is this location. And the third charge is minus 2Q. Minus 2Q is to be placed at the origin. You know why? They say minus 2Q is where? 0, 0. So first of all, this is not a dipole, because a dipole should be what? Dipole should be having negative Q and positive Q. Here we have 3 charges. So what I'm going to do is, I'll split this minus 2Q into 2 charges. This minus 2Q into 2 charges. Look at this. I'll put one minus Q here, another minus Q here. Both of them together will make minus 2Q itself, but they are slightly apart now. They are slightly apart now. So what have I done now? I have just broken that minus 2Q into 2 pieces. Broken that minus 2Q into 2 pieces. Then that is minus Q and minus Q. Then what? I'm taking one dipole here. Look at this green dipole. Dipole is always from where to where? Negative to positive. You know this. Negative to positive. There is another dipole along x-axis. That is also from negative to positive. Now you got 2 dipoles. You know how to find the resultant, right? How do we find the resultant of 2 dipoles? Complete the parallelogram. Complete the parallelogram. Draw the diagonal. Complete the parallelogram. Draw the diagonal. So that is the resultant dipole moment. P net. So how to find P net now? P net is equal to root of P square plus 2PP cos 90. Why cos 90? Look at the angle, it is 90. Look at this angle, this is 90. Both the dipoles are identical in all senses. So that is why I'm taking P for both. I'm cutting this because cosine is 0. What am I getting now? Root of P square plus P square is root 2 P square, which is root 2 into P. Root 2 into, what is dipole moment? Dipole moment we learned before. One of the charges multiplied by distance between the charges. Here the distance between the charges is A. So root 2Q into A. And where is it passing through? It is passing through this location. That location is where? The coordinates of that location are A, comma A. A, comma A. The coordinates are A, comma A. Why? Because you're going straight up from A, you're going straight to the right of A. So that location must be A, comma A. But there is still one coordinate missing. What is that coordinate? Z coordinate. I had told you the configuration lies in XY plane. So Z coordinate must be 0. Z coordinate must be 0. So basically, the dipole moment is what? Root 2 QA along the line joining x equal to 0, y is equal to 0, z is equal to 0, and x equal to a, y equal to a, and z is equal to 0. Option B is the correct answer. All of you got this? So let us move to the next question. Two parallel infinite line charges. Read the question, please. Two parallel infinite line charges with the densities plus lambda coulomb per meter and minus lambda coulomb per meter are placed at a distance of 2r in free space. Okay. What is the electric field midway between the two charges? Okay. So first of all, this question is about linear charge distribution. Linear charge distribution. We have learned that there are three types of charge distributions. Number one, linear charge distribution, where the charges are on a line. Second one, surface charge distribution, where the charges are on a surface. Third one is volume charge distribution, where the charges are distributed in a volume. Okay, so basically there are three types of distributions. I'm talking about the linear charge distribution here. What is the equation for linear charge distribution? Is equal to lambda divided by 2 pi epsilon 0 r. Lambda divided by 2 pi epsilon 0 r. Okay, lambda is called linear charge density. Now let us draw the configuration here. First, we have a line of charges. It is having what? They say it is having plus lambda. And then there is another one that's having what? That's having minus lambda. Another parallel line. It is having minus lambda. And then what? They are placed at a distance of 2r apart. Look at that. The distance between them is 2r. And they are talking about electric field midway between the charges. Midway means right in the middle. Right in the middle. So that is the point. So I can say that this distance is r, even this distance is r. How to find the electric field intensity at a point? This is having positive charges. Why? Because they say first line has positive lambda. Second line has negative lambda. Okay. And as you can see, if you put a plus 1 coulomb, see what's happening to it? Plus 1 coulomb is repelled by the left line to the right. This plus line, no, plus line repels plus 1 coulomb to the right. Plus 1 coulomb to the right. This line repels plus 1 coulomb to the right. What does the other line do? The other line, look at the other line. Minus line attracts this plus 1 to the right. So as you can see, both the intensities are to the right. So how to find E net? E net is given by E1 plus E2. E1 plus E2. What is E1? Lambda by 2 pi epsilon 0 r. What about E2? That is also lambda by 2 pi epsilon 0 r. Never put negative sign. Why? Negative sign is already factored. Direction is given, no. Direction is to the right because the right plate is negative. So you don't have to put negative again. So that makes it 2 lambda by 2 pi epsilon 0 r. 2 and 2 are getting cut. Finally, you have the answer lambda by 2 pi epsilon 0 r. And the correct option is lambda by pi epsilon 0 r. And the correct option here is option C, lambda by pi epsilon 0 r. This is the correct option. All of you got it? So let's move to the next question now. Question number 6. Read question number 6 now. A thin conducting ring of radius r is given a charge plus q uniformly distributed over its circumference. The electric field at the center of the ring due to the charge on the part AKB of the ring is E. Read the question carefully. A thin conducting ring of radius r is given a charge plus q uniformly distributed over the circumference. So you are giving charges to this ring. Can you read that statement again? The first statement. It is a charged ring, right? A thin conducting ring of radius r is given a charge uniformly distributed over its circumference. So everywhere on the ring there is a charge. Okay. Everywhere on the ring there is a charge. Then what are you doing? The electric field at the center O due to the part AKB. See the part AKB? This is the part AKB. Due to the part AKB is given. What is EAKB? EAKB is given as E. All right. Electric field due to that part alone is E. The electric field at the center due to the charge on the part ACDB. So we have to find the rest of the arc, ACDB. First arc is AKB. So basically this is the ring I'm talking about. This is the ring I'm talking about. Until here it is blue, the rest is red. The red part, electric field is E. You have to find the electric field to the blue part. Hope you understood the question fully. So I can tell you something. By symmetry, what is the electric field at the center? Electric field at the center should be 0. Because if I put a plus 1 coulomb here, this element repels it in this direction. There is an opposite element which will repel in the opposite direction. Similar way, this element repels this in this direction. There is an opposite element which would repel in this direction. So for every element on the ring, I'll draw a bigger one. Look at this. For every element, for example, this is my point at the center. I put a plus 1 coulomb. This element has a positive charge, which will repel this plus in this direction. But there is an opposite element here, which has a plus charge, which will repel in this direction. So they'll cancel out, right? Similar way, I take another element here that will repel in this direction. But there is an element here which will repel in the opposite direction. So by symmetry, I can say electric field at the center is equal to 0. Correct. And what is electric field at the center? It is the sum of electric field due to both the arcs. Am I correct? EAKB plus EACDB. EAKB plus EACDB should be equal to 0. They are asking you to find EACDB. EACDB. So how to find EACDB? It is minus of EAKB. And I know one thing. EAKB value is E. So I can put E here. Negative of EAKB means what? AKB's electric field is in this direction. So negative of it means opposite to it. Which is in which direction? From O to K. O to K. So I can say along OK. E along OK is the final answer. Answer is option B. All of you got it? No, let's do it again. Okay, so see this, I'll do one more time. Look at this. See this, I have like a big circle. Look at this, I have a big circle. Yeah, no problem. I have a big circle, all right. And then I split that into two pieces. One is like a quarter of a circle. So they have even named it. Look at this. This guy is called AKB. Okay, and that little arc is called AKB. The other arc is called what? ACDB. The smaller arc is the smaller arc. Look at the smaller arc. The smaller arc is AKB, and the bigger arc is ACDB. So there are two arcs. Hope you understood until that part. AKB and ACDB. And I know one thing, that if I put a +1 coulomb at the center, that will be equally repelled by opposite elements. Look at the small element which has a plus charge. It will repel this +1 in this direction. But there is an opposite element plus charge which will repel it in the opposite direction. Similarly, if I take an element here, there will be an opposite element here. If I take an element here, there will be an opposite element here. If I take an element here, there will be an opposite element here. So everywhere on the ring, if I take an element, there is an opposite element, right? Which will cancel the electric field out. This is what you mean by the term symmetry. By symmetry, since the circle has equal charges everywhere, by symmetry, electric field at the center is what? I could say electric field at center should be equal to 0. Is that understood until here, Dia? Understood, the guys? Electric field at the center should be equal to 0. Okay. Electric field at all right, Daniel. Thank you. Emma. And Priya. Electric field at the center is equal to 0. Got it? Hope you got it. Then what? And that electric field is due to which all parts? There are two parts, right? One is, there is an element called AKB. There is an arc called AKB, as you can see. And there is another arc called ACDB. AKB and ACDB. The sum of them should be equal to 0. The sum of them should be equal to 0. And what I want to find out is ACDB, which is equal to what? Get that term to the right hand side. You are getting minus EAKB. But they have given EAKB as what? Electric field due to AKB is E. They have given it as E. But it is in which direction? Negative of AKB. Negative of AKB. Where is AKB's field? Look at this. This is AKB. AKB's field is in this direction. So negative of that means what? It is in this direction. That is from where to where? O to K. That is why I said E along O to K. E along O to K. So this, the arrow is where? Actually, it's very simple. This arc is repelling this +1 in this direction. So the rest of the arc is repelling this +1 in this direction. So finally, the answer is E along OK. Understood now? Let's move to the next question. Can you read this question? Two similar balloons filled with helium gas are tied to L meter long strings. A body of mass M tied to another ends of the strings. Tied to the other ends of the strings. The balloons float in air at a distance r. If the amount of charges on the balloons is the same, then magnitude of charge on each balloon will be. I'll draw the figure, then it is very easy to do. So I have like a balloon here. All right. I have a balloon. All right. I have another balloon. Okay. Anyway, I'm just drawing the lines. This is first line. This is the second line. And there is another balloon. All right. And right here, we have like a small mass suspended. Yeah. Okay. And these are at a distance of r. This is what is given. First of all, this is having a charge of q. They are asking about the charges. This is having a charge of q. This is also having a charge of q. And which means what? Both are identical charges would mean that they are repelling each other. They are repelling each other. Okay, they are repelling each other with a force. Okay, so first of all, there is a force called tension on the wire. Do you remember what I told you about tension? If a wire is loose, there is no tension. But if you keep a weight suspended on it, there is a tension. I told you in the last class that tension is outwards from the body along the string. From the body outwards along the string. So look at this. I'm drawing the first tension. First tension is drawn on this one. Okay, I'll draw it one more time. Look at this. First tension is drawn on this one. All right. Okay, that is the first tension. And tension may be split up into two components. Which are the components? One here and one here. Okay. All right. So I can call this tension. This angle is theta, means, have they given theta? No, yes. They have given theta as this little angle. This angle is theta. Okay. So then this must be what? This must be t cos theta and this must be t sin theta. Similar way, the other wire also has a tension. Look at this. This wire also has a tension. Same tension. Why same tension? Why same tension? Because this wire connects balloon and the mass. Even this wire connects balloon and the mass. And the angles are same. So exactly identical conditions. So obviously tensions are equal. So I'm going to write this is also theta. I'm going to split this also into two components. What are the components? That tension also may be split up into two components. Tell me which are they. One is this way, another is this way. What are the components? Straight up is t cos theta, to the left is t sin theta. And what is the force in the downward direction? Downward direction is mg, weight acting downward, mg. Now let us put the condition for balance. Tell me, the total upward force is what? The total upward force is what? There are two t cos thetas. So t cos theta plus t cos theta, that's going to be 2t cos theta. That is balancing the downward force, which is weight, mg. Equation number 1. I repeat one more time. What have I done? I have taken each string independently and I have drawn tensions on each wire. First wire has, this wire has a tension which is marked in red color, and that tension is broken into two components. One is t cos theta, the other component is t sin theta. Similar way, on the other string, I have put another tension, but that is also same because exactly similar conditions, right? So t cos theta and t sin theta. Then what? The downward force is weight. Weight acting is mg. So what is the y direction components? What are the y direction components? T cos theta and t cos theta together is 2t cos theta. That is the total upward force. That balances the downward force mg. So I can say 2t cos theta is equal to mg. Then what about t sin theta? T sin theta is to the right. Okay. T sin theta is acting to the right. And there is somebody who balances that force. What is that? It is the electrostatic force. Electrostatic force. Electrostatic force, no? Or you could say it this way. Take it this way. It's better to take it this way. Look at this. Where is T sine theta? T sine theta, as you can see, to the right. T sine theta is to the right. Okay. Even this T sine theta is to the right, to the left. And what causes that T sine theta? It's because of the repulsion between these guys, right? Right? Because of the repulsion between balloons. So I can say T sine theta is basically caused by electrostatic repulsion. If you didn't understand that part, please tell me. I'll tell you one more time what I have done. There are two strings. Both the strings have same tension T, and both the tensions are resolved into T cos theta and T sine theta. And in y direction, I added T cos theta to get 2T cos theta is equal to mg. Because y direction forces are to be balanced. Because somewhere along the question they say the system is in equilibrium. Even otherwise the system is in equilibrium. Then what? In x direction, what is the force? T sine theta is the force in x direction. T sine theta is the force, as you can see. And who gives that T sine theta? T sine theta is to the right. Why does the balloon go to the right? Because of repulsion, electrostatic repulsion. So I got T sine theta as mg. Now divide them. Equation number 2 by equation number 1 implies what? T and T are cut. I get half sine theta by cos theta is tan theta is equal to f by mg. I'm not done yet. I can cross multiply. I can write it here. I don't have space, enough space. So I'm just putting it one more time. Half tan theta is equal to, what is electrostatic force? Kq square by r square. Kq square by r square and mg. Now, what I want to find is q. You know how to find it. You can take q square from this. Take the square root. You will get the first option as the correct one. Understood this, all of you? I'll tell you how to do that question one more time. First of all, when you have, we have done a couple of questions of this kind already. When you have the question, the first thing to do is to resolve the tension into components. What are the components? For that wire, on the right side, the tension is up, T cos theta and T sin theta to the right. Similar way on the left wire, we have tension T, which is also split up into T cos theta and T sin theta. And then you put condition for balance in y direction. What is the condition for balance in y direction? T cos theta plus T cos theta, 2T cos theta. 2T cos theta balances mg. Because upward force should balance downward force. Then only you will have equilibrium. Then in x direction, how would you write it? X direction, the force is T sin theta. Look at this blue circled one. Look at this shaded one. T sin theta. That T sin theta was caused by what? That T sin theta was caused by electrostatic force. Correct. T sin theta is to the right. Rightward force comes out of electrostatic force, right? So I can say T sin theta is equal to F. Divide equation number 1 by 2 by 1. You are getting half tan theta. T cut 1 by 2 into sin theta by cos theta is tan theta is equal to F by mg. And F value I put kq square by r square into mg. So what we want to find out is q square. So I'll write q square straight away. Q square is equal to, from this, what is q square? What is q square? That will come to the left side. mg r square by 2 is already there. K comes from right side into tan theta. So q will be square root of this tan theta the whole raised to 1 by 2. So option A is correct. All of you got this now? So before going to the next question, I'll do something. You just have to know this. See, if you have to find the differentiation of a quotient, x by y, differentiation of quotient, this is how you do it. Denominator into derivative of numerator minus numerator into, I'll do it one more time. Let me just get this. Okay, I'll write it this way. Okay, I'll tell you one more time. Just give me a second. This is what it is. First point I'm going to tell you, differentiation of a quotient. Differentiation of a quotient. Quotient means division. How to do this? Denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. Okay, so that's a standard rule you have to learn. Differentiation of a quotient. If you have chosen mathematics, you will learn it automatically. Otherwise, you have to learn this. The previous NEET question, high chance of coming in boards also. Okay, so d of x by y. I told you I will be putting challenging questions here only, challenging questions, because I'm trying to make sure that you get 100 in finals also. Okay, and even in NEET examinations, all the questions. So you have to learn a little bit of mathematics as well. So this is what it is. First point is this, differentiation of x by y. Differentiation of a quotient is what? Denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. Second thing you have to know is d by dx of x square, x raised to n. This is something you know, n x raised to n minus 1. Exponent into x raised to exponent minus 1. Exponent into x raised to exponent minus 1. Now the third point is, what if it is d by dt of x raised to n? You have to do n x raised to n minus 1, and then again you have to do one more differentiation. And over the last year, you have seen this couple of times. This is called chain rule or function of a function rule. I repeat the points one more time. First is differentiation of ratio. Differentiation of ratio is done how? Denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. Okay? Okay? Okay, then second thing is d by dx of x raised to n. How to take it? How to take it? N x raised to n minus 1. N x raised to n minus 1. D by dt of x raised to n is what? Look at this. What is the difference here? Here you are differentiating with respect to x. Look at this. Here you are differentiating with respect to x. But here you are differentiating with respect to time. So in such cases, when the variables on numerator and denominator are different, you will differentiate it one more time. Okay, that is what we do. So just keep this in mind. Don't worry, I'll do it again. So let us see that question one more time. This is our question. See this? I have the question here. I have even drawn the figure to save time here. The figure is not given in the original question. Two equal charges are separated by a distance d. A third charge placed on a perpendicular bisector at a distance x will experience maximum Coulomb force then. So I repeat, two equal charges are separated by a distance smaller d. So look at this. I have drawn the figure. First charge here is q. Second charge is also q. And they have a separation of d. That is what they have given. So half is d by 2, d by 2. Then on the perpendicular bisector, you know what perpendicular bisector is? If we have a line like this line is called perpendicular bisector. It is also called equatorial line. Perpendicular bisector or equatorial line. That line is called perpendicular bisector or equatorial line. Okay. So I'm going to find the force at this point. Where is that point? At a distance x. So look at my figure now. This is a q. This is another q. and they are separated by distance d. Total distance is d. So half would be d by 2, d by 2. So I need to find the force on this plus 1 coulomb. Okay. Okay. So tell me, this distance can be called what now? This distance that can be called r. I can call it by the name r. I can call it by the name r. Okay. That r will be what now? Root of x square plus d square by 4. Thanks to Pythagoras theorem. I repeat one more time. Look at the context one more time. 10 more minutes. That's what I take. Two charges q and q. They are both positive and they are kept at a distance. So this distance is d by 2. This distance also d by 2. And on the perpendicular bisector, I take a point. Where is that point? At a distance x. That's all about the geometry of the figure. And then r is hypotenuse. Hypotenuse is root of x square plus d square by 4. Keep that in mind. Let's come back to the figure and see this. Tell me what's happening. This plus q is repelling this plus in this direction with the force F. See, I've drawn an F there. Do you see that? Why is that F in that direction? Because as you can see, this plus q is repelling the plus 1 I put there. I put a plus 1. I put a plus 1 here. I put a plus 1 here. Okay. And that plus 1 is repelled with a force small letter f. I call it small letter f. And similar way, this plus q also repels with same force F. Now split it into two components. What are the components? F cos theta and F sin theta. This is F cos theta. This is F cos theta. Similar way, upward F sin theta, F sin theta. F cos theta cancel out. F sin theta add up. So total force will be what? 2F sin theta. I repeat one more time. Look at this. So what have I done here? I have just put a charge plus q here, a charge plus q. Both are giving forces F, 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 F. And first force F, look at the red circled one. First force F is resolved into F cos theta and F sin theta. This is F sin theta. Similar way, the other force is also resolved into F cos theta and F sin theta. Here, F sin theta components are added up. F cos theta components are cancelled out. They are in opposite directions, right? They are cancelled out. So eventually the force is 2F sin theta. So 2 into, I'm putting it here, okay? 2 into, what is the force? KQ square divided by R square. Look at the distance is R. R square into sin theta from the triangle. Can you tell me what it is? Opposite side divided by hypotenuse. Opposite side divided by hypotenuse. So what I'm getting is 2kq square into x by r square into r. It is r cube. So 2kq square into x by, what was r? R was x square plus d square by 4 the whole raised to 1 by 2. So r cube will be what? X square plus d square by 4 the whole raised to 3 by 2. Understood until here? Right until here. I'll do the next part then. All of you understood until here? Just write until here and tell me when you're done. We will do the rest of it. I don't have enough space to write there, okay? We need to find when the force is maximum. They are asking to find the condition at which force is maximum. I'll tell you how to find it. Right until here? Tell me when done. Nothing. I've taken what? I've taken the triangle and half the length is d by 2. Hypotenuse is taken as r and the distance, perpendicular distance x. All right, Nanando, thank you. Then Pythagoras theorem. By Pythagoras theorem, I can write r as root of x square plus d square by 4 the whole raised to 1 by 2. That is Pythagoras theorem, okay? Hypotenuse is equal to, this is Pythagoras theorem I have written. R is equal to x square plus d square by 4 the whole raised to 1 by 2. So I am finding the force. The force due to one charge is small letter f. That is resolved. Look at this red circle. The force due to one charge is small letter f. That is this red circle. That is resolved into two components, f cos theta, f sin theta. Similarly, on the other side, f cos theta, f sin theta. Here, cos components are cancelled out, being in opposite directions. Sin components are being added up. So f cos theta plus f cos theta is going to be 2f cos theta. So 2 into, f sin theta plus f sin theta is 2f sin theta. That is 2 into force, kq by r square. Sin theta from the triangle is x divided by r. Opposite by hypotenuse. Opposite by hypotenuse. X by r. So I get 2kq square into x by r cube. And x by r cube is given x square plus d square by 4 the whole raised to 3 by 2. So I'm writing this equation one more time. Look at this. This is the equation for force now. I'm writing that force equation one more time. See what I'm doing. Force is equal to 2kq square into x divided by x square plus d square by 4 the whole raised to 3 by 2. Okay, and I'm going to tell you the condition for maximum. If something is to be maximum, their differentiation should be 0. That is a condition called condition for maximum and minimum. If something is to be maximum, differentiation should be equal to 0. df by dx is equal to 0. So I'm going to differentiate it. df by dx. See what I'm taking. 2kq square is kept as such. I open a bracket. 2kq square is kept as such. I have opened a bracket. It is like a ratio. Do you remember what I wrote for ratios? Denominator into, that is denominator, x square plus d square by 4 the whole raised to 3 by 2. Into derivative of numerator. What is derivative of x? Differentiation of x is 1 minus numerator into x. Derivative of denominator. I won't have enough space there. I'll write it one more time from the beginning. Okay. So hear me again. What is the condition for maximum and minimum? If you want to think about maximum, why should I think about maximum? Because they say maximum force is experienced when maximum Coulombic force, df by dx. So these are like rank deciding questions. Okay. So that is why it becomes so tough. Only 1 or 2 questions in the whole paper will be like this. Okay. So 2kq square into this for condition for maximum and minimum is this. I told you the differentiation should be 0. So I'm going to differentiate it. Now see what I'm doing. I'm going to take df by dx of that guy. 2kq square into, I open the bracket, denominator into, denominator is this. Derivative of numerator, derivative of x is 1. Numerator into derivative of denominator. That is, be very careful there. Derivative of denominator is what? Look at this. Power into function raised to power minus 1. Did you understand what I did? I'm trying to take the differentiation of this denominator. How to find it? Power into, power is 3 by 2. 3 by 2 into that bracket. x square plus d square by 4 the whole raised to 3 by 2 minus 1. I'm not done yet. I have to differentiate one more time. What is x square's differentiation? It is 2x. Why did I do it? Because this is called function of a function rule or chain rule. I told you about chain rule. Divided by denominator square. What is denominator square? Denominator square is when I take what do I get? X square plus d square by 4 raised to 3 by 2 square. Square means they are cut. So you are getting what? Simply this. This is what you get. And you should equate this to 0 and solve it. You will get the final answer. 0 is equal to this, but this can't be 0. Why? Because they are constants. So the bracket has to be 0. I'll equate that. Okay. So let us do it one more time. Listen carefully. Then the question is completely done. All right. So I told you how to find the net force. Once you have calculated the net force, you got to do what? You got to differentiate it and then equate that to 0. Equate that to 0. Okay. So this is the condition for maximum. Even for minimum, it is the condition. Maximum, minimum. Okay. Maximum force. But minimum force they won't ask. Maximum force is given by dF by dx is equal to 0. So see what I'm doing. I'm taking one more time. Look at this. I'm differentiating 2kq by r square. 2kq square. That is a constant. I won't touch it. Into what about bracket? Denominator into. Do you remember the formula? Denominator into derivative of numerator. Differentiation of numerator. What is differentiation of numerator? Differentiation of x is what? Differentiation of x is 1 minus numerator into differentiation of denominator. What is differentiation of denominator? Power into x square plus d square by 4 the whole raised to 1 by 2. Okay. I'm not done yet. I'll do that part one more time. So I have done what? Look at this again. Denominator into derivative of numerator. Differentiation of numerator. Differentiation of simply x is 1 minus numerator into differentiation of denominator. 3 by 2 x square into x square plus d square by 4 raised to 1 by 2. But x square is in a bracket, so you have to differentiate it one more time. What is the differentiation of x raised to 2? 2x raised to 1 divided by, I don't care what the denominator is, denominator square is equal to 0. This has to be 0. Why has that to be 0? Because I said df by dx has to be 0. But this cannot be 0 as it is a constant. When you cross multiply, you get what? Only the numerator part becomes 0. What is the numerator part? X square by d square plus d square by 4 minus 2 and 2 are cut. 3x into x, 3x square into x square plus d square by 4 the whole raised to 1 by 2 is equal to 0. So I cut it. Oh, this had like this was like 3 by 2. Finished. X square plus d square by 4 the whole raised to 3 by 2 is equal to, that will go to right side, 3x square into x square plus d square by 4 raised to 1 by 2. So let us cut the terms now. Here, this is getting cut. That is getting cut with this. That is getting cut with this. I'll do it again. From this part, I'll write it again. So what I'm doing is, I'm going to equate this to 0. d by dx of f is equal to 0. But you know one thing for sure? This cannot be 0. because it's a constant. K is constant, Q square is constant. This denominator when cross multiplied will become 0. So what I have is something like this. X square plus D square by 4 the whole raised to 3 by 2 minus 3x into x, 3x square into x square plus D square by 4 the whole raised to 1 by 2 is equal to 0. So let's get to the right hand side. X square plus D square by 4 the whole raised to 3 by 2 is equal to 3x square into x square plus D square by 4 the whole raised to 1 by 2. So I can cut. This is like, if I cut on both sides, what do I get? What do I get? Understood until here, all of you? Can you write this down until here? So let's have a quick recap of the question one last time. In the first part of this question, we found the folds as 2k q square into x by x square plus d square by 4 the whole raised to 3 by 2. Now what I want is, I want this force to be maximum. What is the condition for force to be maximum? For something to be maximum or minimum, the first derivative should be 0. Differentiation should be 0. So I'm finding df by dx here. How to find it? 2kq square into, I'm taking the formula, denominator into derivative of numerator minus numerator into derivative of denominator. Say it again. Denominator into, I'm writing it here, okay? Denominator into, see this? I'm going to take df by dx. Denominator into. So first of all, 2kq square I'll keep as such, into denominator into x square plus d square by 4 the whole raised to 3 by 2 into derivative of numerator. What is differentiation of numerator? Differentiation of x is 1 minus numerator into x into differentiation of denominator. What is differentiation of denominator? Differentiation of denominator. First, power into x square plus d square by 4 minus raised to power minus 1. Power minus 1 means 3 by 2 minus 1. That is why I wrote it as 1 by 2. Then the function inside has to be differentiated. X square's differentiation is 2x. Then what Daniel was asked is correct. D square by 4, it does not need to be differentiated because it is constant. By, I don't care what the denominator is, I simply write it as denominator square, as long as the left side is 0. Because 0 into that is 0, right? So that will give me 0 is equal to, what is this? X square plus d square by 4 the whole raised to 3 by 2 minus 2 and 2 are cut. 3x into x, that is 3x square into x square plus d square by 4 the whole raised to 1 by 2. And a little bit of mathematics will do the final step. Tell me, I'm getting this to the left hand side. So 3x square into x square plus d square by 4 the whole raised to 1 by 2 is equal to x square plus d square by 4 the whole raised to 3 by 2. So if I cut 1 by 2 raised to 1 by 2 here, there 1 by 2 gets cut. Simply x square plus d square by 4. Why? What is the logic? Because x into x raised to 1 by 2, if I have x into x raised to 1 by 2, left side is x raised to 3 by 2. Am I correct? Right side. X raised to 3 by 2 may be written as x into x raised to 1 by 2. So x raised to 1 by 2 term gets cut, right? And finally, what I have is this. I have 3x square on the left side. 3x square on the left side is equal to, right side is x square plus d square by 4. If 3x square is taken to left side, you get 2x square is equal to d square by 4. What I want to get is x square. So x square will be cross multiply d square by 8 and x will be d by 2 root 2. 2 root 2 is square root of 8. So the final answer is d by plus or minus d by 2 root 2. So answer is option C. All of you understood this? Anybody wants it again? Okay, so we have finished all the 10 questions from electrostatics I put. So last class I took around 1 hour to finish 3 questions. So I thought I would need more time. That is why I scheduled like 1.5 hours today. So, but this question is done, finished. I'll send the slide to the group now. You practice these questions again and again. I'll come back with another slide on the same topic in the next class. Okay. If you didn't understand any of these questions, please do get back to me anytime. I'll help you with it. Shall we wind up for the day?